Hi everyone, welcome back to chemistry. In this video, I just want to talk about really briefly how to balance chemical equations that have polyatomic ions in them. Because we learned how to balance chemical equations last week, but we didn't have any equations that had, our polyatomic ions in them because we didn't know what those were yet. But from now on, you might have those in your equations that you need to balance. And there's a couple tricks to kind of make your life easier when balancing these. So I wanted to show you that. So what I've done is I've copied this equation over here. So we're just gonna solve it over here so we have lots of room. And what you'll notice is that one thing I did here was I put these parentheses here around my phosphate. Because what is this thing? That's phosphate, right? What charge does phosphate have? Phosphate. Yeah, it has a 3- charge. Yeah. And remember, if you're still trying to memorize these, there's some flashcards in Canvas for you that you can use. Okay, so it has a 3- charge. It's a polyatomic ion. It's called phosphate. What if I had phosphite? What would be the difference? Yeah, you'd have one less oxygen here. It'd be PO3, 3-. What I did was I added these parentheses right here, and you don't necessarily have to do that. I did it so that it was a little bit easier to see that that is one species. It's one polyatomic ion, okay? But you don't have to add those. I just added them so it'd be a little bit easier to see. And then what does this AQ mean again? Yeah, that means aqueous, dissolved in water. Yeah, aqueous. We learned about that in lab the other day. Okay, so with these ones with polyatomic ions, I approach them like I do any other balancing chemical equations problem to start out. So the first thing I always do is I draw that line to separate my reactants on the left from my products on the right. So, and then I like to say that I have at least one of everything. So I just put a 1 as the coefficient in front of everything. And that way it just shows that I know that if these things are reacting, I have to have at least one of each of these things, right? Okay, and remember, why are we balancing chemical equations? Well, we have to balance these because we need to make sure that we're obeying the law of conservation of mass. So whatever atoms we start with, whatever mass we start with, we have to end with that many atoms. Or if you're weighing this out in lab, you also need to end up with the same amount of grams that you started with. So the next step is to list all of the different types of things I have, the different atoms. So let's go ahead and start on the left there. We've got Na, which is sodium. And then what you'll notice is that this PO4, this phosphate, is the same on both sides. What do I mean by that? So what I mean is that it didn't break up into two different things, right? We don't have phosphorus on its own or oxygen on its own on this side of the equation. It stayed just as phosphate. Sometimes you will have equations where, especially with oxygen, you might get an oxygen on some other species over here. And that can mean that you're going to have to break up your polyatomic ion when you list your different types of atoms. So you would be like P and O, and you would just count them individually as atoms. But when they stay together, it's much easier to view them as one thing when you're balancing these equations. So don't break up that PO4. So I'm going to list it as phosphate, PO4, on this side, and I'm going to count it as one thing, okay, because it doesn't break up. Okay, so let me get rid of this highlight here. What else do I have? I have magnesiums, and I have chlorines. On the other side, I also have sodium, right? I have my PO4 stayed together, so I have my phosphate, I have my magnesium, and I have my chlorine. Okay, so now it's a matter of figuring out how many of each of those things we have. So how do we figure that out? Remember, the coefficient tells you how many of this whole thing you have, this whole ionic compound. So remember, because these are metals and nonmetals. Metals plus nonmetals means ionic bonding, right? So here's a metal, Here's a metal. Here's a metal. And what you'll notice actually that's kind of interesting, just as a side note, you'll notice that these two, they switched over here. So what happened was your sodium was originally bonded with your phosphate and your magnesium was bonded with your chlorine. And now on the right side, you've got magnesium now with phosphate and your sodium with chlorine. So, and we'll talk about, there's an actual name for that kind of bonding, and we'll talk about what that is, or that kind of reaction, but kind of interesting. Okay, so that was just a side note. So let's go ahead and count how many of these things we have. So for sodium, how many sodiums do we have there on the left? Yeah, 3, because you're going to multiply this one by the subscript next to sodium. So I have 3 sodium atoms there. They're actually sodium ions because these are ionic bonds. And PO4, how many PO4s do I have? Do I have 4 of them? No, why don't I have 4 of them? What's this 4 actually going to? There's 4 of what there? Just your oxygen, yeah. So every PO4, every phosphate has 4 oxygens and 1 phosphorus. But if you look at the whole, this whole thing, and remember we're not splitting it up, how many of that whole thing do we have, of that whole phosphate? Yeah, we just have 1. Yeah. If we had more than 1, what would go here? If we had 2 phosphates, what would go there? Yeah, you'd see a 2 there. Okay, and you actually do. You see a 2 over here. But let's not get ahead of ourselves. Okay, so we have 1 phosphate because there's an imaginary 1 here because we don't see anything there. And this coefficient gets multiplied down there. 1 times 1 is just 1. So we just have 1 phosphate right now on the left. Okay, what about magnesiums? Just 1, right? And chlorines? 2, yeah. Okay, on the right, how many sodiums? 1, yep. How many magnesiums? Or I'm sorry, how many phosphates were next? How many phosphates? So this coefficient gets multiplied where? By that 2, right? It doesn't get multiplied by this 4 because that's just the oxygen. So how many phosphates do I have here? Well, when we see that little subscript there, that 2, that means I have 2 of whatever's in those parentheses. So what's in my parentheses? Well, I have PO4 in my parentheses, and we know that there's a little charge here. So if PO4, I have 2 of them. Oops, I forgot my minus. Oh, it's there. It just looks weird. So I have 2 of whatever's in the parentheses. So this would be one of my phosphates, right? And this is the other one. Okay. Okay. And we need to make sure we count our coefficients still. So if we have a 1 here, we're going to multiply that by our 2. And how many total phosphates do we have? Yeah, 2. Okay, if this was 2, if our coefficient was 2, how many phosphates would we have? Yeah, 4, because it's saying we have 2 of this whole thing. And within those 2, we have 2, or within each of those things, we have 2 PO4s. Really weird, but stick with me. Okay, but I don't want to change that to 2 yet, so I'm just changing it. I'm just keeping it at 1 and counting how many I have. All right, how many magnesiums? Yeah, 3. We've got that little 3 subscript there next to our magnesium. Okay, and then how many chlorines? 1, yeah. Okay, so is this balanced? No, it's not balanced, right? We want to change. Well, what if we change this to 2? Because I'm noticing that I want 2 phosphates. So let's go ahead and make this a 2. And now we have to update how many of each thing we have. So I put a 2 in front of that sodium. And now I have how many sodiums? Yeah, 6. 2 times 3 is 6. Okay. There's also a 2 in front of our phosphate, right? Because this 2 gets multiplied by everything here. So how many phosphates do we have now? Remember, there's an imaginary 1 here. Yeah, we have 2 phosphates. So let's make this 2. And that's why I put that 2 there, is because I was noticing I had a 2 over here and I wanted to have the same amount on the left. Okay, we're still not balanced though. So let's see, what else can we do? Well, I have a 6 for my sodium over here. So I guess we're gonna have to make this 6 as well. So let's go ahead and make this 6. I don't think there's any way around that. So let's go ahead and put 6 here. And then how many chlorines do we have? Yeah, now there's 6. Okay, but I'm looking at this and I'm thinking, well, this 2, it goes into 6, right? How many times does 2 go into 6? It goes in 3. So what if I make this a 3, and now that 3 gets multiplied by the 2 on the chlorine, so I'm going to have a 6 here. And then how many magnesiums do I have now? Yeah, 3. Yeah. So just like any other balancing problem, you're still going to go through those same steps. The key for these, though, is recognizing that this is one thing. It's all bonded together in the reactants on the left side, and then it's all bonded together on the right side. So we can treat it as just one species. Okay? Okay, I hope that helps. If you had broken it up and you wanted to count phosphoruses and oxygens alone, it would still work. It would still work, but it's just a little bit more work for you. But you can do it, and so if that helps, if it works better for you, you can totally do that. Likewise, if you did see it kind of broken up over here and there was some kind of oxygen happening over here, you would have to break up into separate atoms. Okay, let me know if you have any questions, and I'll see you later.